Okay, so we're going to look at our second problem now, which looks really quite simple, I think, but has a few tricks in it, and I think it's a worthwhile problem doing because it reviews a bit of our algebra techniques, for one thing, and it will call on us to think a bit logically. How many terms must be taken in the series, harmless looking series, to make 208? Now, yes, I do realise you could do sort of running totals to derive an answer, but that's not going to help us in more complex examples that we might come across, for example, in a test situation. I think I'd like to start with a formula just to settle the nerves a bit. And what I'm going to do is, because I don't know the last term, and I can't think of a surefire method to find the last term right at the moment, what I'm going to do is revert to the more complex of the two formulae, and it's this one. Okay, and then I'm going to look at that formula and work out what it is I need to find out. How many terms must be taken? Well, it's really asking us how many terms will be in the series that lead to a sum of 208, isn't it? How many terms will be in the series? That's asking us to find n. Now, the problem here is, really, that n appears in two places. Okay? I'm predicting that this will lead to us needing to solve a quadratic equation. Okay, well, we do know some things though. We know the value of a and d is easy to sort out. So those are three variables. I've got two of them that can be easily identified from our series at the moment. And so without any further ado, what I'm going to do is substitute what I know into our equation. And of course the other thing we do know is that the sum comes to 208. So we can say that. We can say 208 must equal n, which is to be determined, square brackets needed for the moment, 2 times a. Well, a is 5, so I'm not going to put the 2 times 5 in there, I'll just cut straight to 10. Plus n minus 1, don't know n yet, so that's got to stay there, times
positive 6.
Positive 6. The common difference, d, is 6. It's that, take that, or that, take that. So either way, it is 6. Good. Okay, square brackets still needed because I've got round brackets inside. So therefore, Sn equals 208, which equals n minus 2. Let's just see what's going on in here. So I'm going to get rid of my square brackets. I'm going to have 10 plus 6 times n is 6n, and then minus 6, isn't it? Okay. And so the best I can do at the moment is to say that 208 will equal n over 2. What have I got here? 4 plus 6n. 4 plus 6n. Okay, let's get rid of the parentheses, the rounded brackets, and we do that with some fairly basic expansion. Okay. Now, n over 2 times 4, that's quite clearly going to equal 2n, isn't it?
Yep.
Okay, 4n divided by 2 is 2n. And then I've got this horrible thing here, 6n times n over 2. It sounds to me like it's
3n squared.
very good, 3n squared. Now you can see, my prediction was right, we do have a quadratic equation to solve. Okay, but let's rearrange a few things and I might temporarily get rid of the Sn there. So what I'm going to do is set my quadratic equation to equal 0. Okay, so 3n squared plus 2n, so I'm just writing out the right hand side of my equation first. Then I'm going to subtract 208 from both sides, and that will equal 0, won't it? Okay, you can reflect on how I got there in a minute or two. But I now have a quadratic equation to solve. I can't simplify that equation through by dividing through by a common factor. There is no common factor. The 3 and the 2 is a complication there. So I've just got to solve it. Now, it was minus 208, wasn't it?
Yeah.
equals 0. Okay, I could use a quadratic equation to solve. I love the quadratic equation because it works for anything. Okay, but this one can in fact be factorised and hence solved without too much fuss. I'm going to use the product sum number routine. Okay, so the product, recall, is achieved or found by doing what? Product means times, of course, so that's a bit of a hint.
3 times minus 208.
Very good, it is. I'll write that up so you can see where everything's coming from. And that's going to equal 624, except it's negative.
Yes.
The sum is simply the
Middle term.
yeah, it's the coefficient of the middle term, and that is quite clearly 2. And now I get into my guessing game, where I've got to think of two numbers that when multiplied give me negative 624, and when added give me 2. That might look horrendous. I mean, the factors of 624, there's probably a lot of them. However, this is giving us a few hints. What's the 2 suggesting?
There's not much there, there's not, yeah, they're close.
It's not much, they must be very close together. They must be very close together. What's this telling us? This negative sign.
That one of them has to be a minus.
Yeah.
One,
Okay.
one has to be.
And that is because one of them's got to be negative, because only a negative times a positive, or a positive times a negative, will give you a negative. So we're looking at two numbers that are really quite close together, and the larger of the two must be positive, because our sum is positive. With that in mind, what I'd recommend here is that maybe you start with the square root of 624. Okay, that's not going to be too apart, but it's going to be a good starting point.
Ross, 24, 26. So negative 26.
Okay, so what we did there was find out that the square root of
negative 24.
624 was 24.97. So obviously I'm not after that number. That's not going to work too well. But I can round down the 24.97 to 24. Whoops, 24. And the other number will be 26. Let's just see if, now, the sum is positive. So the larger of the two must be positive. That means we're looking at negative 24. Okay? Let's just confirm by calculator or otherwise that times that does equal that.
It does, sir.
And it does. Good. So that wasn't too traumatic. Looking for the hints. Now remember, what we do with these numbers is we use them to break down the middle term. That will enable us to factorise in pairs and hopefully solve our equation. Okay, so therefore 3n squared. Now remember, the order you put them in does not matter. That's nice to know. You can't make that bit up. Okay. Now what we do is we factorise in pairs. That means we pair up our terms and factorise away. Looks quite difficult, but you're going to see that it's not that bad at all.
3n and then n minus 8.
Good. So 3n is the common factor between that term and that term. We open up our brackets and ask ourselves always, what do we times that by to get back to there? It's n minus 8, isn't it? Okay. So, what I am predicting here is that what appears in my second bracket will be the same as what appears in my first bracket.
26.
Once you realise that, this becomes very easy. So what I'm going to do is cheat a bit and go like that, and then ask myself, does 26 work when I expand this out? 26 times negative 8 is?
Minus 38.
Let's hope so.
It is.
It is. Good. Very good. So I've factorised in pairs. Now what I do is I write down the common factor. Therefore, n minus 8, that's a common factor for that expression and that one there. And then I simply write down what's outside of the brackets. Using this, and that, oops, that plus shouldn't be there, should it?
No.
No.
About me, I don't even know who she is.
And
Then you can't touch
equals 0. Now remember, this is where the null factor theorem comes into play. What we're saying is if that is true,
And equal
if
that.
that times that does equal 0, well either that must equal 0 or that must equal 0. Null factor theorem. If AB equals 0, A equals 0 or B equals 0. So n equals 8 or, that says or, didn't turn out too well, 3n plus 26 equals 0. Now, can you think ahead a bit and have something to say about this possible solution, or not?
Yeah, because that one will be minus 26 over 3.
Yeah, if we did go ahead and solve that, well, let's do it, I suppose. We've got a solution there, or, so n equals 8. This happens quite a bit with quadratics.
Negative 8.66.
Couple of problems with that solution, so-called solution. First is it's negative. You can't have a negative term in a series, really. Okay. The other thing is it's a rational number, but it's not an integer. That's not always a problem when you're in these sort of problems, but the fact that it's negative certainly is a problem. So we just reject that as a solution. So our conclusion is there are 8 terms in the series. Okay? Well, we must take 8 terms in the series. Any questions about that?
Lovely. Proving it
Thank
once
you.
again.
Alex, can you hit the red button, please?